So yeah, today we are going to talk about perception. Essentially, it's the part of our visualization knowledge that relates to how we see. And when you see some of these slides, you'll realize how powerful, but also how weird our eyes are. But then you learn how to take advantage of this knowledge when you design visualizations, or honestly, just design interfaces in general. So a lot of these concepts today will be really useful for you for your design career or any sort of presentation career. So I highly recommend this lecture to anyone. Let's start with this notion of visual memory. Our visual memory is really capable and can hold a great deal of information. It can help a lot of items within it. That's why we're so good at navigating the world. And then psychology researchers have investigated just how powerful our visual system is and how quickly it can remember things. But before we get into some of the examples, I'm going to show you a series of pictures. The first set, I'm going to ask you to just pay attention, close attention, and then we'll see how many of them you remember. I'm just going to go really quickly. So please, when I start clicking, just pay attention to these images. All right, are you ready? Hit thumbs up if you're ready, and I'll start. All right. 1, 2, 3. All right, let's do it. All right. We saw a lot of pictures. Okay. So what I'm going to show you now is to show you a subset of those pictures and ask you to tell me if you've seen it before or not. Ready? Let's go. Have you seen it? Yes. Have you seen this? Yep. Have you seen this? Absolutely. Have you seen this? Yep. You all right? So see how we saw about 30 pictures, and you can remember, even if you see those images for a fraction of a second, exactly, you just know because your visual memory is so good, things immediately. What I just showed you gets us to this idea of how we perceive the world, right? We can think about our perceptions of how we think about the world. Let me just make Mehdi co-host so he can do things while I give the lecture. Make co-host, confirm. Okay. Yeah, the way we perceive the world can be categorized into these two distinct processes, bottom up and top down. You can also think of them as data driven and knowledge driven. So we're going to see some examples of what this means, right? So bottom up processing is the attentional guidance purely by externally driven forces. For example, visual stimuli that appears salient because of their inherent properties relative to the background, such as light source in a dark room or a bright red balloon. So when you look at this image, you don't need any sort of knowledge, anything to be able to understand the differences between the yellow umbrella and all the other ones. You just immediately detect it. It's just there on the screen. But it pops out to you because it's so different from the others. Your eyes are built to be able to detect this, detect these differences between stimuli. And this yellow is just a stark contrast, and you can immediately see it. So we don't need no prior knowledge to understand these differences. And that's bottom-up processing. But when you look at when you're at the airplane's cockpit, you just don't know what you're looking at. There's just too many stuff. You're not a pilot. So everything here is just random stuff. Some buttons, there are buttons. You can detect that there's screens here. You know that there's what they could do, but you can't work them unless you're a pilot. Do we have any pilots in the room? I would be really excited if there's a couple of pilots in our class. But probably not. We need another type of processing to be able to use our eyes to do this. And that is top-down processing. That refers to the internal guidance of our attention based on our prior knowledge, plans, and current goals. Okay? So let's take a look at the difference between them. What you're looking at here is a bunch of circles with some lines carved out of them, right? Yeah, but exactly. You see a cube here. So your bottom-up person is telling you that you are looking at a set of circles, and then your eyes are immediately also seeing this cube as well, right? Your brain is just immediately building this shape for you. When you look at the whole thing, you don't, when you're not looking at these individual circles, your brain creates that shape of the cube for you. And it's really hard not to see it. It's just really hard. This cube is there. Can anyone just tell me if you see something in this image, but don't tell me what it is? Ah, I don't want you to spoil this, because the whole point is that a lot of people, but it's fun. A lot of people don't see the dog. They just see a lot of different points, but you could see it. Who wasn't able to see this? Anyone that just see a bunch of blobs? Yeah, exactly. Yes. But if I show you this, highlight it for you, and then take it away, I think you're going to be able to see the dog now. Yeah, very cool. That's the point. The idea is that sometimes your bottom-up processing cannot detect something, but then you gain knowledge, you gain expertise in something. Now you've become an expert in detecting the dog in this patch of blobs, black blobs, right? And now you can't turn it off. I think what this teaches us is that you might see things that others don't. It's very common. And this is something that we have actually seen in politics and everywhere else, but it also happens with our eyes as well. You just see things that others don't, and it's just, and you just need to help them see it. And if you can't, I don't know what to do. But that's the way our brains work. Some people can see things and some people can't. Right? So the bottom-up processing is using our visual input to drive our perception, but then the top-down influenced by our expectations and our knowledge. Other things such as motivation, beliefs, and prior knowledge can shape and bias what we see. What do you see here? Okay. A few people see a seal, some see a donkey. The people who see a donkey, can you see the seal? Yep. If you try to focus, immediately you might see a seal like a donkey, but if you focus, you could see the other thing as well. right? Maybe it's your preference, right? Maybe. I can't prove it, but maybe. The horse lover goes, oh, it's a horse or it's a donkey. And then the seal lover, and seals are my favorite animals. I don't have it with me, but I have a bunch of seals in my house. You can see a seal. Okay? Another example. What do you see? Duck, duck bunny, rabbit and duck. You see both of them. Scissor shadow. Yep. Yeah, this is also some ambiguous things, right? You could see this as a bunny, you could see this as a duck, you could see both of them. And then you're using color, you can make it less ambiguous. But again, another example of our eyes could see things differently. So you don't see the world, you see your brain's predictions of the most likely world. So now can you tell me which one of these tables is longer? You guys are smart. Just go with don't go with the knowledge that you know it's a trick question. Yes, at the first glance, it's a tough route. They are the same size, exactly the same size. It's the same exact shape. I'm just rotating it. But now your brain can see that these are the same size. The way the legs are stretched far into the distance makes our brain think that this is taller because our brain predicts like a perspective. It makes us think that this is a narrower one because our brain works really hard to maintain size and shape constancy. Closer objects are larger, further objects are smaller. This is the way we've been trained, right? But the actual graphics, these are just equal. So just to reiterate, we see our eyes when we get some light into our eyes, right? From the left, from this side, we see some information, right? The first stage is the early stuff. We process things in parallel really quickly. We can detect color, texture, shape, and spatial attributes. But then the stage two is serial, is slower. We can identify objects using our memory. We can see something as a dog or not, and we can understand spatial layout. So this is called pre-attentive. These are some words that you're gonna wanna think about as a designer. And these are post-attentive. Again, these are just models of how we see, not exactly how the brain works, but like this is just how models that are useful. Bottom up, data driven, top down, goal directed. So pre-attentive processing is that neurons in eye and brain responsible for different kinds of information. We see orientation, color, texture, movement, etc. Arrays of neurons work in parallel, occurs rapidly, almost automatically, and then information is transitory, briefly held in iconic storage. And it's bottom up, data driven. It's about the data in the world. Post-attentive is sequential, it's top-down, involves working and long-term memory, is placed into subsystems for object recognition and for interacting with the environment, increasing evidence that support independence of systems for symbolic objects manipulation and for locomotion and action. So there are some evidence that there are multiple systems working in this sort of post-attentive processing. So it's where it's interfacing with the verbal and linguistic portions of our brain. And then we're talking about these two different locomotion and symbolic objects, and latter interfaces with motor systems that control muscle movement. So that's how our processing works. So some things are done pre-attentively without the need for focused attention. So can you find the number of threes in this image? Really hard to tell. 2. I think there's more. Yeah, it's really hard. Yeah, I think there's probably 4. But if we do this, and I want to keep showing you this example because this is one of the most important things you want to learn. Highlighting is just very important because it happens pre-attentively. The moment you do this, you find it. That's done. It's over. Boom. Boom shaka waka. I don't know. I'm a boomer. Do you even know what boom shaka waka is? I don't know. It's from a game. NBA Jam. Hell yeah. NBA Jam, exactly. One of the most fun games ever made. You just gotta see it. It's a 2-on-2 Sega game that you play basketball, and then it's just so good. Nothing yet made like that. Anyways, so some of the pre-attentive tasks: target detection. Is something present? Boundary detection. Can elements be grouped? Region tracking. Can you follow a visual feature as it moves in time and space? Counting how many elements of a certain type are present. So let's do some practice with pre-attentive processing, okay? So I'm going to ask you, is there a red circle on the left or right? And just tell me as quickly as you can. Boom. Quickly. Boom shaka waka. Nice. Left. All right. Again. But yeah. Color, hue, is pre-attentive. We can quickly find it. So is red circle present? Was it easier than the previous one to find? No, it wasn't. It was harder. Is there a red circle present? Yep. Was it easier than the first one? Was it? I don't think so. Anyways. Okay. Is the red circle in the left or is the red circle on the left or on the right? Cool. Yep. How about this? Yep. This is harder because you have to detect multiple things. You have to filter color and you have to filter shape and you have to look at 2 things. You have to compare both sides. This is pretty post-attentive. This is hard. What was that one more challenging? Because conjunction search normally cannot be detected pre-attentively. When you want to do a comparison of 2 superimposed features, right? These are called distractions. And these distractions may vary along multiple target properties like color and shape in this case. So this is happening serially. You have to do one and then you have to do the next one. That's why it's harder. Still quick, but it's harder. The more features you add for your users to look for, the more this is going to happen. So that's why in a lot of interfaces, you want to try to get people to know where things are. And in this course and some of the other courses, you're going to learn how to do that. So you look at some of these examples. You can look at some of these examples here. With a lot of these examples, it's fun. I can share the link if you're interested. But there are some more pre-attentive visual features. So line orientation, even in this small case, you can quickly detect that the orientation is different. You can quickly detect that length of one of these is different. You can detect the one that's closed versus the others. You can quickly detect the one that's got a different size. You can find the one that's got a different curvature. You can easily detect the density of objects. You can estimate sort of the number. So number estimation is quick. You can easily detect the hue. You can pretty quickly find the one that's got a different color intensity. You can find the one that has intersection. You can find the 2 lines that are terminated at each other. You can find that it has some 3D depth. very quickly. Flicker is very pre-attentive. You can easily detect the direction of motion. You can easily detect differences in velocity of motion. And you can easily detect differences in lighting directions. So as a designer, you can use these visual cues in your advantage. But sometimes in these, there is interference. So we have congruent and incongruent stimuli, and you'll see an example. So when, for example, you have the text blue and the color is the same, this is congruent information. And then when you have the text purple, but the color is green, you have incongruent information. So when asked to name the color of the word, it takes longer and is more prone to errors when the color of the ink does not match the name of the color. Is anyone ready to speak and read a few things on with voice on? Does any brave person want to volunteer? So I just want to say that, incongruence takes longer and is more error prone. So just read it for yourself. I'm going to try it. Yellow, red, purple, black, orange, purple, red, blue, green, yellow. So when you read the text, it's easy. Let's say the color of the, try to say out loud the color of the printed font. It's harder. Red, black, orange, green, blue, orange, yellow, red, yellow, black, green, blue, red, black, green, blue, orange, black, red, blue, yellow, black, green, red, blue, red, orange, and green. It's really hard. It's hard because your brain needs to process two information and decide what stimuli it needs to filter out. It's hard. So you sometimes want to not give incongruent information. So now we're getting, yeah, it's really hard. It's really hard to do this. Now we're getting to another set of psychology information that helps, as it's old, but it helps with design a lot. So I'm going to show you some information about how elements in visual scene are processed as a coherent whole rather than individual elements. So there are a bunch of different principles. So the Gestalt principles are figure ground, proximity, similarity, symmetry, connectedness, continuity, closure, and common fate. So let's start with figure ground. I have some example, but we're going to go quicker just for the fact that this is something that you all have seen. So figure ground describes how our visual system tries to help us recognize objects by differentiating the background from the subject or the focal object. Figure ground relationships are not easily predicted by simple rules, but instead are the result of complex edge detection and shape detection by our visual system. Such processes are most likely probabilistic based on a prior object that we have seen. Some people perceive white as the foreground, a goblet, right? And some people see black as the foreground, right? It depends on how your brain does it. So you might have not seen this example. So okay, you see a fish or a person, but I think it's like more close when it's oriented like this. It's like more close to a woman because at least for in my head. But you could rotate it, and so it makes it more likely to see the fish. It is a fish, I think. So in general, it's just such a good idea as a designer to use this principle to differentiate foregrounds from backgrounds. You can do this in multiple ways and it still works. And sometimes when there is continuity, it still works, but it just becomes a little bit more ambiguous, right? The foreground and background becomes unclear. Do you see how in the design of Spotify, I should change these guys are leaving Spotify, so I shouldn't use them as an example. But you see how like this notion of foreground and background, even with subtle differences, is working with interface design? It's pretty useful. So now we're going to look at proximity. The distance of these dots is almost equal in this group. And then it is equal in this group as well. Okay? But when you look at them together, because of a group of dots closer to each other here, what's up with the meme? I wish I could show this in the stream. Oh my God, don't make me laugh. I need to edit this out. You're giving me too much work because I need to just then go and figure this out. No, I like it. It's good. I can't show names and stuff. So I'm getting the text from somewhere and just showing the text because we don't have permission to show names of people and stuff. So, anyways, moving on from that meme, which is, oh my God. Let me take a minute. This is so funny. You guys are doing a whole Twitch chat around. Like, you guys, in a few days, you're going to start sending memes and like emojis and stuff. Cool. Anyways, the whole point of this notion of proximity is that you will see these objects as one group and these objects as one group, even though the distance between this specific point to this blob is the same as these groups. So here's an example that I made. Because these sets of groups are in closer proximity to each other and these sets are closer, it's so easy for you to then say, oh, all of these circles are about One Piece and all of these circles are about Jujutsu Kaisen, right? It's so easy. It's just your brain does this automatically. So now we get to similarity. It says that elements that look similar are seen as a group or as a whole. In this example, rows dominate due to similarity, right? Both color and rows and shape works as this idea, right? And you use this in a lot of your interfaces, and you're going to use this in your visual design as well. So by using circles as elements for people and then for projects using rectangle, you can create interesting design elements, right? So next week, when you're designing your personal website, because that's your next assignment and your next lab, get ready, you can use some of these elements in your design. So you can do all sorts of different things using combination of proximity and similarity to create interesting groupings in your design. So let's look at symmetry. The idea of symmetry is that when you have symmetrical objects, they're going to be seen as a whole. Remember, Gestalt is about how you get groups of objects and see them as a whole, right? You see them as a whole, but then when it's like this, you tend to see them as two separate objects. So symmetry also works. Connectedness is really interesting. When two objects, it overrides the rest of the elements. It's such a powerful principle. When two things are connected with something, even if they're dissimilar, they're going to still be seen as part of the same group. So even the sizes are different, the shapes are different, you see them as the same group, right? And you use this type of design in interfaces. You see this a lot in like Amazon and all of them other tools. You connect them so you know it's a process. You change this shape a little bit so you know they're part of the same group, but you also know that the first one is already happened and you're waiting for the next two to happen, right? So you're combining these two elements to create a good intuitive design, right? So you can see that now shipping has also done. It just naturally happens, right? So now we see these as two sets. We can connect them, right? And just add to it, right? Proximity works, and then by connectedness, you can reinforce that notion of connectedness. It's harder to see these as part of the group because the sizes are different. But again, if you connect them again, it overrides them, right? It works with color as well. So now you see those four at the top as four separate things. But the moment that you connect them with color, you will see this as a whole. And it also creates this notion that now you have selected this page and you have done something. Again, these are principles. We're going to try to use them in visualization design. Continuity is very interesting. It's just the idea that when you create like a curvature and things are happen in like a nice smooth order, you just see them as part of a group. And you use this in many cases in your designs because these are actually cut by this line, but you still see this green line and this red line as a whole. This happens in Google Maps. This design is used a lot. It uses circles to show a walking distance, right? And then still you see this as a line, as a whole. You perceive it as a whole, and it's really useful design. Closure, things that form, and we've already seen this, things that come together to create some sort of closure, you perceive them as a whole. And this is used in many different designs. And common fate is really interesting. When you have this sort of animation, you can see that you can perceive these as a whole, even though in the beginning they were in a row. But now that they move together, you see them as a group. This is a very used design principle. It's very prevalent in the interfaces that you do. And again, in visualization, we can use the same thing. I'd like you guys to get creative with these ideas, but try to remember these are things that these are an arsenal of tools. These are different hammers that you can tool to nail things. So now let's practice. It's hard to practice when people don't speak. So what type of, just type, what type of principles can you detect here? And describe to me where it is if you want. Yeah, go for it. Okay. Yeah, yeah, very good. Proximity, what do you see in terms of proximity? Let me see. Shared fate, continuity, similarity. What do you see in terms of shared fate? When this happens, I tried to click. I'm easily fooled. I thought this is actually Amazon. I tried to click on this arrow. Yeah, I guess that works. Proximity in the categories. Yeah, you're right. When the page moved, that works. Yes, exactly. Shared fate for carousel items. Very good. You see a lot of other things, these subtle font differences. For example, here, these belong to the same group, but these are a different group. These have different functionalities, right? Foreground, background is super clear here. It's used with these boxes. Proximity is used everywhere. Okay, let's move on. Netflix also, this is embarrassing. This is last year's favorite, the shows that I was watching, like the shows that he was suggesting. It's not too bad. Anyways, Netflix uses this proximity, it has similarity, it has closure. Mo was really cool. I agree. Right? Even though this one is cut out, you know that it's gonna continue. It just your brain tells you that. So I highly suggest go to these different websites and try to think. Now that you know some of the vocabulary of the design, go and think about what the designer is doing. Today's music theme is Massive Attack. You see how YouTube is doing it. I like the design of YouTube. Foreground, proximity, these are all of these are here. These belong to the same group with this font, and these proximity, these belong to the same idea. And then based on similarity, even though these are not in close proximity, you know that these give you the same amount of information. Same goes on. I'm just going to skip this. Just do this practice with yourself. Okay, we're getting to color. There's two ways to think about color: luminance and brightness. So it's essentially, I think there's and I forget the term for it. I think it's candela or something, is a standard unit for luminous intensity or brightness of a light in a specific direction. Measured amount of light coming from some place. Brightness is perceived amount of light coming from a source. This idea is very different on screen versus on paper. It's a nonlinear function of the amount of light emitted by a source. This is some formula for how sort of the sensation and intensity work together. One of the important things is that this idea of color, luminance, and brightness is important for foreground and background, for them to differ from each other. You can easily read this text, but you cannot read this text. It's really hard for you to see it. So when you design, you want to focus on brightness and intensity to create contrast. So now we're going back to the vocabulary that we learned about visualizations. So can different colors be used for categorical variables? Yes. There is some suggestion, but where there's 12: red, green, yellow, blue, black, white, pink, cyan, gray, orange, brown, and purple. And you can differentiate these. But sequences are more hard, more difficult. Can you order these from low to high? And this is hue. Probably not. But there is a way to encode sequential data, and that is brightness, right? It becomes so much easier to model sequential data using color. Okay? So there's a really nice tool, colorbrewer2.org, that you can use. It gives some tried and tested set of colors that you can use for categorical data, for numerical data, etc. And it has accessibility options as well. Try to not use rainbow color scale for quantitative data because it's hard for people to know the differences. Try to use the same hue and change the brightness or the intensity or the opacity or something. It becomes easier to read. You can change saturation. You can make things darker and lighter, and you can change the hue, but these are perceived as light and these are perceived as heavy. So some colors are considered heavier. This has heavier color, larger size, balanced by more variety, more density, and complexity. So a little bit more color tip. Just if you use too many colors, it becomes harder for people to see it. So often less is more. Red, green is center of field of view. Edges of retina not sensitive to these. And black, white, and yellow are in periphery. Adjacent colors that vary in hue and value, use those. Pastels, not highly saturated colors, it's better to use them for larger regions. And it's really good to use color for grouping things and helping with search. So you want to highlight things using color, so then people can then go and detect shapes and sizes and stuff like that. but color illusions also happen. Here's an example. It's super odd. I can never get used to this, but your brain sees A and B as different, even though they have the same color. Just so odd, because the background of the color is, yeah, this is just really weird. I just hate my lizard brain for this, but the background affects how you perceive a color. Okay, this one is the same. I just put something here and you see the colors as the same because some shading. It's just so hard to be forced to unsee it. It's just how our eyes work. So now before we're going to repeat this, but these are the last slides of the lecture. We're just going to do a little bit of practicality because we're going to start doing some visualizations. Here's some of the things based on these perception ideas that we learned. So the idea is that visual elements are different. We just learned that, right? Some are more noisy to detect. Right? So you can identify positions. You can see the differences between positions so much more easily. This is also position, but like size differences are just more difficult to see. Color differences are more difficult to see than position. Same goes by angle. These are the same data, but you see them differently. So when you compare these two, when there is no zero in your chart, people overestimate the differences between these items, even though the data is the same. So the choice of the baseline is a really important choice. We're going to repeatedly say these stuff to you for this class. These are some of the most important things for when you create data visualizations, right? But just start with these few rules of thumb. Try to have zero when it's useful. Not always, sometimes, and I can show you examples later. So when having a zero is actually misleading, a zero baseline. See, this bar chart is showing a difference between Obamacare enrollment from March 27 to March 31st. They want to say, oh, look, there's so much difference, right? But if you actually start from zero, it will just look like it's nothing. And as I said, zero baseline is not always the honest baseline. So taking a small visual increase on the left and stretching it is the honest way to show climate change data. You know why? Because temperatures do not start from zero normally, right? In Fahrenheit, they start from 50 or 40. So if you start from zero, you're doing a dishonest way of presenting the data. It's harder to read when baselines are different. So you can compare these blue bars, but you cannot really compare the sizes of these orange bars. So using grouped bars in general makes it harder for people to see. What you can do is that you can now compare the sum of both super easily. But for orange, it becomes really problematic. So you want to figure out a way to do this. And sometimes differences between these lines are seen differently, even though they are the same. This goes back to the idea of intensity. So try to not use intensity on intensity. So color on color is just a bad idea because of the examples that we saw. As you can see, we just see them differently. And sometimes it's hard to read. So in general, vision is really powerful for global statistics. So you can easily identify the minimum in a group, the maximum in a group. You can find the max, the min super easily. but making comparisons is slow. Now, if you want to compare two different lines, it's just really hard. You just have to think and do some processing. If I ask you, how many games have decreased in sales from year 1 to year 2? But you had to do the comparisons one by one. It's slow. Okay? But we can do some things. We can design. So instead of just using these different colors, we can group them. We can highlight the year. Instead of using color to denote year, we can just highlight the year with text. Now we can easily just know what we're looking at. And then we can just tell people that information. I'm getting back to the idea of highlighting. If you want to say to people, oh, these are Diablo 4 or Diablo 4 is the game that decreased, why not highlight it? There's this iPhone that it keeps coming in. Okay, so using the things that we learned in this class, you can start creating data visualization that work for what you want to do. And then you can also use some storytelling. Diablo 4 has decreased in sales from 2020 to 2021. You've highlighted it, you made it work, and boom. Now you can tell your story very quickly. You can do this in a different way. You can help people read the actual amount. You can do the actual calculation for them. So now they know how much it has decreased. Not only you tell them the story, they've all had increase in sales, but Tetris was like not much, but then you know how much it has reduction in sales. So doing calculations sometimes, the thing that Mehdi taught you, is useful because you often don't want to get people to just go and do the calculations in their head because it's hard. So the whole idea, and this comes from one of my favorite visualization researchers, and there's a paper in your list of readings that is written by him and a lot of other great visualization researchers. It's basically most of the things that in terms from psychology of visualization that you want to learn. And the idea, the main policy for visualization, the main goal of visualization for you should be to first simplify things, don't overcomplicate things, structure information, and then tell a story. So consider what they need to remember, consider that comparison they need to make, help guide the eyes. And then the idea is that because you don't want to just get people to move their eyes from here, right? That's why legends are not always good. Try to avoid them when you can, and then tell your stories. Transform the data to get users closer to where they need to be. If simplicity is useful, be minimalist. But if you want to be fun, if you want to be weird, then do weird things. But for your design, start with being able to communicate things and then introduce your sense of style. Right? So be maximalist if you care about something else. All right. And then in general, these are the last couple of slides. In design, emotions matter. The way you create some text might influence how you interpret it. So then after all these principles, we're going to try to get our emotions and our storytelling and how like we create interesting things in the game as well. I love this example. And I think that was the last slide. Okay, any questions? With my promise, we did it exactly in an hour. If you don't have any questions for Monday, I'm going to come in, start with some basics of HTML and CSS, just some of the basics, but you all should know some of that, right? It's a prereq, but we're going to repeat it. We're going to have some GitHub. The next assignment is for you to create your personal websites on GitHub so that most of the assignments that we'll have will be available for you as a portfolio for everyone to see. And so you're going to start making really cool stuff. So be a designer, do cool things. And thank you for coming on Thursdays to hear me talk so I don't talk to myself on a camera. If there's no questions, we can adjourn. I'm going to stop recording. Thank you, everyone.